did a really good job explaining R and Python to you guys. So hopefully I can cut my session short and basically go through some of the simple stuff with you guys. A quick intro about myself. My name is Danny, and I graduated from actuarial science from Accra Uni, and did Master of Accounting at University of Sydney. Over the last 10 or 15 years, I've been working mainly in the actuarial space for insurance companies such as Allianz, Suncorp, and a few years ago, I also did sort of a startup, like an investment fund with my friends, but that didn't go well. So now I'm working as the principal data scientist for Toyota Finance for about 1.5 years now. So hopefully I can share some of the real life projects with you guys today. And I guess, like, earlier the plan was to sort of break up the session into 2 sections, like, helping you guys to understand or how to learn Python. But after hearing what Tim has taught you guys, I think that's, like, excellent coverage what is about Python, and like, how you guys should kickstart and learn Python. So I won't repeat that in my session here. And so in my session, I will be mainly focusing on the real life projects, basically help you guys to understand what are the rationales behind some of the data analytics and some of the codings, and what does that coding support, what that help you to do. And hopefully that put you into the context of what you can use or what you can learn in the future. So I guess someone, because I'm outside, so someone else please help me, like, to flip through the presentations. As I said before, because team already done a very good job, so I'm probably gonna go through the first few slides very quickly. So first of all, a little bit background of what a data science. I understand most of you guys probably in finance, like, in accounting or actuarial space. But as you know, data science is quite a sort of hot topic these days. And I guess, regardless the name or, like, the what the job is called, but actually data science is very similar, or, like, in a lot of ways fundamentally no different to the analytics or, like, actuarial stuff you guys doing. Basically, their portfolio, understand more about their projects using the data that the company has. And I guess most recently, because of the free sort of softwares, like, for example, Python and R, because of the coding capacity increase, and that made a lot of data analytics, like, more accessible and more capable. Yeah, I think more and more people, analysts, or, like, more and more young professionals like you guys could be able to help you guys help the business to clean, manipulate data, integrate data, analyze making predictions, building machine. So this is a quick intro about data science. So next slides. Next slide. All right, thanks. Yeah, so this is just, like, try to help you guys to understand, like, where why understanding the programming language Python or R, like, will give you guys such a big advantage, like, going into the future job field, because it's, like, as you know, these days there's more and more data available for yourself. for the companies, and therefore, as I said before, there's more like a lot more cool stuff or a lot more insights that could be driven from the big data. Experiencing delay. Can you hear me? I think someone got delay, or you can hear me okay. Oh, delay. Can you hear me now? No, okay. Okay, so I guess if that's the case, I try to speak a bit slower, if that's fine. I'll freeze occasionally. Right. I apologize, guys. So I think like where I am, probably the reception isn't that perfect. So I try to slow down a little bit. No, it's fine. Okay, cool. Right. So I guess where I was. Right. Yeah. The data source. So as I was speaking, I think the understanding the programming language, understanding the underlying data, and be able to interpret the data into the business language, or converting the data into business insights, gonna help you and help the business a lot in the future. And like so the more data we have, I think the more sort of value you guys could add to the underlying business. And next slide, please. Here is like some quick examples of data science applications, like or what data can do. I guess I won't go through the details, but mainly like I think you can use data science to understand the customer behavior much better than like just randomly guessing what customer like or using the survey to try to predict what customer might do with the historical data, with like loads of transaction data. And I think like these days it made predicting customer behavior a lot more reliable and like a lot more accessible for different range of business. And also like we can say in the logistic industry, not only in the finance or in the side of things, but also in the underlying logistic business. And you can like using the historical data to forecast a lot of your logistic need, and also forecasting. Say for example, at Toyota, we use a lot of data science models to forecast. And we're like ship them to different ports around Australia. So I think a lot of data and data science models made that capable and made that available to the underlying business. And the healthcare. What do you say that like the disease, for example, like in terms of the coronavirus, and as you guys may know, there are a lot of like models out there predicting the outbreak, predicting the curve, and I think by the data sitting behind the scene. I think the New South Wales government did a really good job, like making a lot of that healthcare, like not healthcare, but health data public, and so therefore understand a lot of the underlying issues. Next slide, please. Yeah, I think this is the probably like skip the slides. So this is like is to say like the in addition to the underlying technical skills, and I think there's like more to the whether you call that data science or data analytics, like at the okay, if you want a lot further down the track, I think it's very important to understand the underlying business and making sure that the model that you build is actually going to be useful. And also the other thing you're going to bear in mind, a lot of that's going to come across in the early stage of your career is going to be clean a lot of data. Really just go into the data, maybe debugging line by line, row by row, cell by cell. So during that process, making you understand what the meaning behind of this data, and make you understand the business context. Next slide, please. The core skills of data science. I think it's the key skills, or the key capacity of being data analytics, or any sort of technical guy these days. You basically gonna form the data, analyzing the data, visualizing, and also turn data into a product. What I mean by turn data into a product is your whether you're building a predictive model, or whether you want to visualize the data, the underlying output by using this data. You're going to be making that, whether it's implementable, or whether it's meaningful for the underlying business. So that requires some of the presentation skills as well. Next slide, please. Yeah, I think this is the part where I probably skip some of the slides here. I think, as I said before, Tim did a wonderful job explaining to you guys what is Python, and the different packages that you guys would come across a lot, or very useful for doing data analytics, doing machine learning. So I think I wouldn't be repeating that again. So next slide, please. Continue. Hear me? I think I broke up. Hello, can you hear me? Okay, let me see. Oh yeah, okay, cool. So next slide, please. Can I go to the next slides? Okay, yeah, and yeah, this one, I'm gonna share the slides with. I think the basic advantage of Python is that for you guys, it's free and it's open source, and as said by Tim, and basically whatever you don't understand, or whatever questions you wanna you want and there must be has been in your situation asking the same question, and also the different packages within Python already done a lot of legwork for you, so you don't have to reinvent the wheel. So I think, to me, and that's the biggest advantage of Python. And the second biggest thing, I think, because at my company, at my team, we're using both R and Python at the same time. But comparing with R, I think Python, you will see Python have a lot of wider application capacity. So that will another big plus for Python. So in fact, at the moment, I'm sort of slowly moving my team from R to Python these days. So I think in my opinion, I think if you want to have a good starting advantage when you go to the job market, I think be able to learn and also understand Python will definitely be a plus for you guys. Next slide, please. Yeah, I'll just skip this one. So next slide, please. Yeah, I think here, I think a team already said it, but I guess I would just sort of stress this a little bit more. I think when you learn programming language that you can learn or you can use to solve your business problem or solve your questions, I think that's probably give you a sort of faster path of learning or be able to using Python. Millions of different within Python, but I guess starting with the principle, which is the question you're asking yourself. Okay, I wanted to achieve this goal, but how these different programming packages will help start Google alternatives that you can use or you can play around with Python. Next slide, please. Yeah, this is I guess some of the very useful and very popular which if you want to have a how would I say very efficient way of manipulating the data or efficient way of building some simple data science models. I think these are the packages worth looking at. And I think Tim already mentioned Panda. The other very common packages are NumPy, SciPy, Skitlearn. And in terms of visualization, there's some very cool visualization packages out there already. You can have Matplot. You can have Seaborn. So I guess in the next few slides, I won't go into the details with these packages, as I think Tim already did a very good job, demoing how the different packages works and how you can install these different packages. I guess my recommendation is install Anaconda or Jupyter Notes and install some of the packages and start having fun with it. And next slide, please. Yeah, I guess I want to go into the details. We can skip this one through. Next slide, please. Yeah, next one. Sorry, guys. I'll just I just don't want to repeat what you guys just learned 20 minutes ago. And the next one, please. This is Panda. Yeah. Skitlearn, yeah, that's building some of the machine learning models. Next one, please. Yeah, that's some basic plotting tools. Next one, please. Yeah, this one is a bit more bit more advanced, and you can build a lot more interactive tools out there. And next one, please. Yeah, so here, I want to, go through a quick, real life example with you guys, and basically, explain the keys. And here I'm using a sort of a quick project that I have done, a few months ago. I think that basically the business problem is very simple. Understand the customer behavior, and we want to understand how different customer reacting to the price that we quote to our customers, whether that's a car price, whether that's a finance rate that we offer to the customer. Customer data line, how likely the customer converting that quotation into a real contract. That's what we call that conversion rate. As you can imagine, this would be very important for the business because this is a very key how would I say, offer customer the price too cheap, which means we might be leaving too much money on the table, or we've been priced out of the market, which means all our competitors are offering cheaper price than us. So, and in terms of how I guess what we try to do here, instead of having a one-way average number for the whole portfolio, basically we're trying to give the help the business to understand, to say, well, different customer are going to be reacting differently to the price that we offer them, and this is a segmentation, and there's many ways you can try to get that insight. I think that traditionally what people do is to draw the one-way table, two-way table, one line chart or some bar chart, and they're trying to understand that the difference in terms of conversion rate from a one-way perspective. But as we understand, the customer is a lot more complex than a one-way scenario. In real life, there is many factors. There's many different variables affecting the customer behavior. So what we're trying to help the business to understand is to say, right, using the machine learning model, using the data science, how could we put the customer into the different segments, or how we can understand how the different customer characteristics would interact together to tell the business to say, for example, if the customer is is middle age, if the customer is working as a lawyer and his conversion rate is probably very low. Why? Because he may be able to get the finance or get access to the credit in a much faster or cheaper way, right? So these are the the how and why we try to understand this problem. So hopefully this one, this slide will give you guys a very good background or a context of this real life project or real life a problem that we're trying to solve. All right. Yep. Next. Is my is the speed all right? Is am I going okay? Or too fast or too slow? Or I'm breaking up? Can anyone hear me? No? Okay. Oh, good pace. Okay, good pace. Thank you. Thank you, AC. As to now, we have the scope of the project, which is very important. Because without a clear objective of the project, you're just gonna be running everywhere, right? So you're gonna waste a lot of time, wasting your time, wasting business time. What you're trying to do, you understand, okay, look, this is a question, this is a problem. I try to understand this problem. How am I going to do it? All right. So this is a very high level, I guess the steps of timeline, and the key steps are number one, you're going to prepare your data, right? Unless you're very lucky, there is professional data engineering team in your company, which doing this data cleaning for yourself, right? And then after you prepare the data, and we're going to do some preliminary analysis. The preliminary analysis, which is to how would I say, to basically environment, or we're gonna have a peer review. How would you present or convince your peer to say, okay, I have done all the reasonable steps, to check my data. You're safe. You can use data to do all the analysis right now, right? And then I'm going to use model. So it's about what do we say, model definition, or building the model. I think that the key question here is to say number one, which model should I use, right? And number two is what are the factors in the old days, this probably a bit more technical to say, oh, look, we can use GLM, we can choose different link functions, or we can choose logistic link function, or should I use Python, this life of you. And I know there's some packages out there where you can put in code, and the package will help you to try 10 or 20 different machine learning techniques and give you the output. So I guess that's a first to learn the data. Just go out there and try the different machine learning model techniques out there, and see what are the result looks like. What sort of how the AV looks like. That the output looks like from different models. And number two, which variables should I use? Again, I guess different modeling techniques probably give you different result. But I think one thing you have to keep in mind is to say that the variables you use have to have business implications, right? You can't which is meaningful, and which and later down the track, this variable has to be able to implement from a business point of view, or even from IT point of view. And lastly, and which means your model, the results sounds reasonable, or the result of your output of your machine learning models making sense, and you'll be able to explain the logics, and also the model itself validated model, what do you call that, the testing data, modeling data sort of validation, and you can validate on the test on your testing data set to see if the model is predictive. And lastly, after you've done time, you're proud of yourself to say, oh, finally I've done this project. Let me explain to the business how I could convince them, these data science models, all these predictive models make sense. And sort of very quick overview of how we're going to tackle the projects. Next slide, please. Yeah, data preparation. I think this is I guess this is very boring part of the process, but it's super important. And from my sort of personal experience, even my team, and I guess we when we're doing a new project, we probably spend at least 50 or 60% of the time on understanding the data and grabbing the data from different database. And I think the how would I say, the key question here is that number one, like, the data that you want is not always in one place, or it's not always in like, one big nice table. And secondly, you're gonna appreciate that is that not all data is clean. And not like, normally if you're lazy, you can say, okay, well, like, it's a data problem. But if you want to, like, to get the extra value for the business, or you want to differentiate yourself, like, from the rest of the data scientists, like, you're gonna it's much easier for you to add a lot of value by understanding the data than, like, playing around with your modeling techniques, right? So I think that here, like, what I'm trying to emphasize here is to say, like, when we do the data prep, it's super important to make sure we understand the data source, make sure we understand the relations between, like, different data tables. And number 4 is we're going to be, like, very specific about, like, what the analytic data table, which means, like, the final big data set, which including all the information that you need before you can use them to create data science models. Like, we have a complete understanding of exactly what are the variables that we're needing. And the last one, like, the data checks, like, making sure you build in data checks in your code, like, whether it's just a bit more creative. You can say, oh, I'll just pull out some of the highest or lowest number, like, using the check. So these are the some of the how do I say, the next slides. Yeah. I think here, like, I think don't be scared by this table. I guess what I'm trying to say here is that actually very. I think you wanna learn something that the Python, like, sometimes, most of the time they give you a big nice table. They say, okay, here's the big table, like, go around and, like, play around with data. But in the real life, I think it's very important to understand the underlying data sent by data warehouse, like, whatever. They normally they like, they, it's called relational database structure. And normally, like, the data is kept in different places. So some of the, like, where, like, call the customer behavior table, like, when the code happened, like, what the code, a lot of code details going to be kept in that table. Number 2 is your actually contract table, which means, like, when that turned into the contract, that table, we keep all the contract information. And like, whenever customer have a transaction, customer have an update of the record, all the data will keep in that table. And then, like, you would have this customer table, like, which means, like, all the customer information, where they live, like, what their name, like, how old are they, their driver license, like, all that customer sort of information will be kept in a separate data table. So what I mean by all that, what does that mean for you, is that when you want to create, like, a one big sort of analytical data table, is actually, like, you need to try to make sure, like, you merge or link these top data tables, like, with the primary key. So normally, whether that be, like, customer ID, whether that be, like, contract ID or code ID. So it's important to understand the data structure or data warehouse that you're working with, and make sure, like, when you're merging or, like, or linking these data tables, you check, make sure you don't duplicate, make sure you don't, like, merge the unnecessary, like, information, or you merge the wrong information into the data table, because it will give you a lot of headache down the track. Next slide, please. Yeah. So here, like, is a quick example of saying, like, what the end data table looks like. Say normally, say I was like, this is a sort of insurance sort of example. So normally in this end data table, you would have the policy sort of transaction or timing, what do we call that, exposure details, like, in one section, like, maybe on the left or in the middle, doesn't matter. And then you would have all this, like, what do we call that, rating variables, or like, or variables. These are the variables, which means are the factors that are gonna, like, impact your customer behavior or affecting your claims, like, result, or affecting your conversion rate. And then I think on the right hand side of that table, what that normally we would have the response variable. Response variable means that, like, this is the things you try to predict, right? So like, normally, for example, if you want to have the conversion rate, like, normally the response variable is 0 or 1. If you want to have, like, predict the claim cost, or like, or example, like, the write-off cost, your like, the result might be, say, well, this write-off might cost us, like, $2,000, $5,000. So depends on what you're trying to predict, depending on your objective. You would have different response variables at the end of the table. And normally what we do is, like, we will merge a big table, which having all the exposure information, all the rating variables, and the different response variables, or different, say, like, whether you got claim, your, like, your code or conversion rate in one big table. So that way it's just much easier for us to have a, like, different analysis with different purpose later on down the track. So you don't have to prepare the data all the time. Next slide, please. Data validation. I think, like, after you prepare your data, it's very important to validate the data, as I said, or reconcile the data. I think some of the standard stuff that we can do is look at the one way to see underlying factors are reasonable. Say, for example, like, you don't want to see, like, everything, or when you have a factor to say male or female, like, and then you find in your portfolio, in your data, everyone is a male. We don't have, like, female customer, and so this is some, like, reasonableness check that you can do. Next slide, please. Yeah, and I think the other keeping the value of doing the data science models is actually, like, the way that you're structuring your factors. And I think some of the machine learning packages, like, is very specific about the way that you're factoring or you're banging the data. Say, like, the way that you have to bend data. So I guess here it's much easier for you to do this step in the data prep stage, which means that you already have a, like, a meaningful factor band. Taking the raw value. Trend identification. I won't go into the details. Like, I think we see the like, very case by case detail. Basically, like, what are we trying to understand is, like, trying to understand underlying variables. The one-way table or the two-way result is showing is actually in line with what you or the business is expecting. I think that's a trend identification. Basically, preparing yourself, like, before the machine learning or the model building stage. Next slide, please. Yeah, this is the scary chart. So basically, this one is, as I mentioned before, there is the a lot of like, new sort of machine learning modeling techniques these days. And I think this one give you guys very good example of some of the most popular machine learning techniques out there. And for example, if you want to have the what do you call that, the model-based approach, or what's that word? Sorry, I forgot about that word. I forget about that word. Oh, well, I got it. Supervised learning and unsupervised learning, right? So if you want to have a supervised learning, you probably have like GOM approach, or a regression approach. I think here, we can have a linear regression, like an ordinary, regression. And if you have want to have a unsupervised sort of a learning approach, here you could have deep learning approach. You have boosting, you have bagging. For example, some of the most used technique, maybe random forest, or as the and some of the boosting method, probably GBM, gradient boosting method. So these are the quick sort of how I say, high level summary of the different sort of train of thought or different school of machine learning techniques that you may be able to use. And I guess the good news is most of the modeling method is already built into different packages. And I know H2O is have very big team building the and updating the different packages, supporting the different business to play around or to use some of the machine learning techniques. And next slide, please. Yeah, similarly, this is I just give you example, just say, as I mentioned before, skitlearn is a very popular machine learning packages, when you starting building the machine learning models. I think this one is just a very quick summary to say when you're building the different type of models, or when you have different type of modeling approaches, what are sort of packages within skitlearn, or what are the functions within skitlearn that you can use. Next slide, please. Yeah, this is the final sort of presentation slides. It's just give you guys a flavor of what the end result might look like. As you can see, this becomes very quite valuable for the business, because at one side of segmentation, you can say the conversion rate is probably only 20% or 30%, and at the other part of extreme, the give the business all. But they inside the dealer network, or how we presented the idea at the end of the day. Next slide, please. Do we have last slide, or this is last slide? Oh, this is last one. Okay, that's good news. Oh, finally, out of my presentation of the last 30 or 40 minutes. Sorry, guys, my signal is not as good as I expect, and I have to rush through some data, really covering a lot of how you learn Python in the earlier session. And I wish you guys a very safe holiday and enjoy your Easter break.